rise. The Court of Marine Biology is now in session.
Be seated. Today's case, the people versus Placozoa. The defendant stands accused of being too simple.
Your Honor, this organism is barely an animal. It has no symmetry, no organs, and no tissues.
Rude.
Actually, Your Honor, we intend to prove that the Placozoa isn't too simple, it is actually secretly complex.
Placozoa are flat, multicellular animals with 4 main cell types. They look simple, but their behavior and genetics reveal hidden complexity. There are only a few described species like Trichoplax adherens, as well as Polyplactoma mediterranea, but genetic studies show many more undiscovered lineages. They live on warm, shallow ocean surfaces and glide around like microscopic Roombas. Very well. Proceed.
Your Honor, the prosecution claims Placozoa is too simple, but the evidence disagrees. I present Exhibits A through F. Exhibit A, their habitat. Placozoa live in warm, shallow marine waters on rocks, coral, and algae films.
So they're beach bums?
And Exhibit B, their reproduction. They reproduce asexually by fission and budding, but under certain conditions, they reproduce sexually too. They're likely hermaphrodites.
I have many skills.
Exhibit C, their feeding. They use external digestion, basically laying on top of food, releasing enzymes, and absorbing nutrients. Efficient and kind of amazing. Exhibit D, their locomotion. They glide using cilia and can shapeshift to surround food pouches. Exhibit E, their development. They're neither protostomes nor deuterostomes. They branch off very early in animal evolution.
So, they are ancient. Interesting. Please continue.
And surprisingly, the Placozoa is able to do all of this while only being 2 to 3 cell layers thick. Your Honor, let's compare where Placozoa appears on the phylogenetic tree our class built using physical traits. According to our data matrix, Placozoa appears near the base of the animal tree. Its closest relative in our tree is Porifera, sponges, mainly because both lack true tissues. But this is misleading. Similarity in simple traits doesn't always reflect ancestry.
So your tree might be wrong?
Not wrong, just simply limited by the characters we could see. Losing traits over time can trick morphology-based trees.
Sounds like a complexity the court should consider.
Calling the expert witness, Dr. Sequence von Genome.
Thank you, Your Honor. I present a published genomic phylogenetic tree. Genetic evidence places Placozoans not next to sponges, but as sisters to Carnidaria and Bilateria, much higher than the class-built tree suggests. Your Honor, some evolutionary background on the Placozoa. They originated over 600 million years ago, and their ancestors likely branched off from early, other simple eumatozoans. Their exact placement is still debated because their bodies do not leave good fossils due to their anatomical structure.
So, why are the trees different?
Morphological traits such as no tissues or no symmetry are misleading. They may be losses, not ancestral traits. Genetic data avoids that problem by comparing DNA sequences directly. Therefore, your class tree groups Placozoa with sponges, while genomic trees show that they're closer to Carnidarias like jellyfish.
So Placozoa is secretly related to jellyfish?
Surprise!
After reviewing all evidence, biological traits, life history, your class phylogeny, and the published genomic tree, this court concludes Placozoa is not guilty of being too simple.
Let's go!
In fact, Placozoa is a fascinating early branching animal with unexpected complexity, hidden diversity, and evolutionary importance. Case dismissed.
Court is adjourned.